Hello everyone, welcome to VLSI Path. This is part of our static timing analysis series, guiding you from basics to advanced concepts step by step. In this section, we will discuss what are the essential input files required for the static timing analysis, from where we are getting these files, and what they contain. This topic is crucial from an interview perspective, so pay close attention to this. So let's dive in.
First one is the netlist. First and foremost, what will be our design netlist? I'm not saying the RTL code, it's the netlist. That's the gate level netlist. Who provides this? Synthesis team. And what will be the format? Many of you know the Verilog code, right? So that's the module how we define any cell or something module with that module. And here the name of that particular cell which we are defining. These are the inputs. This is the output and the name of that, like which cell we are going to use. That's the example of the netlist. So this is the gate level netlist we use as an input file because it will give us the whole functionality what we are going to use, right? Next is .lib. .lib is the liberty file which have all the PPA information of the standard cell, macros, IPs. Right? This is provided by the library vendor from where we are taking the standard cells, macros, and the format will be this one. The library. Here we have defined library example lib, then the cell name is this one, pin is this one, this pin is input pin, the cap is this, and this pin is the output pin. This is the functionality, right? We are using this N2_X1, that's the cell name, and we have defined the functionality here. So the PPA is like the area or its performance, meaning the speed, meaning the delay, and the power. All of the things will be defined in .lib. Then next is .sdc, that is Synopsys design constraint file. So as we discussed, the false path, multi-cycle path, all are other timing exceptions or the clock delay, right? All the definition will be defined in .sdc file. Again, it is related to functionality. So this will be provided by synthesis team. The format of this file is the create clock command is for creating the clock. These are the input delay and then the output delay and then the false path from this gate ports, meaning from input to output, we have to set the false path. So our analysis will exclude this path. Next is tech file. Tech file is the technology file. So technology, like which technology node we are using. So what are the metal layers we are going to use in that design? What will be the specification of the metal layers, those VRs, like their width, the spacing allowed. So this file, because of this file, we'll get to know the DRCs, right? So who is going to fabricate will provide us this tech file, meaning the foundry. Yeah, so foundry will provide us the tech file corresponds to that technology node which we are using in our design. The format is here we are defining the metal one. The layer is metal one. The type is routing, the pitch, width, spacing. So in this way, in the whole file we define the metal and VR information which we are going to use in our design. Then next is .SPEF file. And this is a standard parasitic extraction format. So the tool used for this is Innovus from the Cadence or ICC2 from the Synopsys. This spec file will give us the RC extraction details when we are done with the routing. So when we use this spec file will give us all the RC delay of the paths, the nets, right? So this will be given by the physical designing team. The format is this one. You can see the net name and then the connection like this, the output, input, and the cap on the resistance. So it will give the RC details. Why we use this? Because in the initial stage, when we check the timing analysis, when we perform, we do not have the exact delay. So maybe you have used a Verilog code, the hashtag 5 or 10, the delay we define. But when we actually do the routing, the delay will get varied, right? The RC delay due to capacitance coupling between them, the delay will get introduced, right? So those exact delay will be there in the .spf file. From here, when we do the timing analysis, it will be more accurate.
That's all for this video. See you in the next video. Thanks a lot for watching.